This is lesson 4.1 and 4.2 out of the Introduction to Algebra book. At Shasta, we combine these two lessons because individually they're very easy concepts to grasp and can be taught very quickly. So together, they make a more full lesson, and they're still quite simple for students to understand the concepts of. So in my class, this is on page 84. And it's lesson 4.1 and 4.2. And combined, we call this lesson Understanding and Comparing Integers. Understanding and comparing integers. All right, so warm up. All right, the warm up for this lesson. Number 1, draw a number line from 0 to 10 and graph the numbers 4, 7 5/10 and 1 1/4 on the line. And problem number 2. Find the value of each expression. All right, A, 4 plus 5 plus 1 squared, and B, 12 minus 3 over 1 plus 2. All right, those are your warm-ups. Let's write down an I can statement here. Let's see, you're going to need a couple of lines to solve that one, huh? All right, so we'll write it right here. Okay, I can understand graph and compare integers. There we go. And we'll talk all about what integers are very soon. So, with my dark green pencil, got a line there, and then I have one little notes piece here, and instead of the upper left where we usually put it, I want to put it right in the middle of our available note space. So easy on the glue. We want to be able to write on this and not have it be wet. That's the beauty of Elmer's. You just don't need that much anyway. Okay, here we go. That's about in the middle, I think. Okay. All right, so let's see. This page of our notes is all about vocabulary. There's some new vocabulary in here for most of you. For some of you, it's kind of obvious, and for others of you, maybe you've seen it all before. It might be a little bit review, but this is generally new for most students at this 6th grade stage. So we'll be talking about negative numbers, positive numbers, opposites, integers, and absolute value. All right, so the first thing we're going to talk about is the positive and negative numbers. So I'm going to draw up here a long number line, let's say about that long, And in the middle will be my 0. All right. And then I'm going to try and make as evenly spaced tick marks as I can here and number them, so they would be 1, 2, 3, 4, 5, 6, and 7. And then again going the other direction, 1, 2, 3, 4, 5, 6, and I've got -1, -2, -3, -4, -5, -6, -7. All right, so there's my integers number line. Now, let's first talk about the negative numbers. It says here that negative numbers are numbers that are less than 0, less than 0. So I'm going to highlight, going down this way, my negative numbers are the ones that are less than 0. Okay, those are the negatives. Now, it says my positive numbers are numbers that are greater than 0. So I'm going to highlight up this way. And those are my positive numbers. Positive numbers are the ones that are greater than 0. So notice that I did not highlight 0. It tells us here that our negative numbers are those that are less than 0. Positive numbers are greater than 0. So what is 0 then? Is it positive or is it negative? Well, it's neither. 0 is neither a negative number nor a positive number. So it's not included when we're talking about positive and negative numbers. Okay? All right, so opposites. Well, what are opposites? Opposites, let's put some examples down. Opposites are two numbers that are the same distance from 0. Well, all that really means is this. Let's write some examples here. So if I have -9, let's make sure I'm in there. There we go. Then its opposite is 9. They both are the same distance from 0. If I have -26, then its opposite is 26, positive 26. If I have -136, then its opposite is 136. Both of them would be the same distance. So if I have the number -4, what is its opposite? Well, it's 1, 2, 3, 4 to 0. So it's going to be 4. 1, 2, 3, 4 to 0. They are the same distance from 0. Right? So when we're talking about integers, the opposite of a number, if it's a negative number, its opposite is its positive number. And if it's a positive number, its opposite is same number but negative. All right, so that's generally pretty easy to get. And so we'll put this over here for opposites. There's our examples for opposites. Now, what are integers? Okay, well, integers are, let me get my red pencil out here real quick. The set of all positive whole numbers, their opposites, and 0. All right. Uh-oh, looks like my red pencil's about to break. Okay, so I'm going to, with my red pencil, circle whole, because that's an important part of this definition. And then right over here, let's write positives, negatives, and 0. And it's important to remember that. 0 doesn't get included in all number sets that we talk about. Like 0 isn't included in positive numbers. 0 isn't included in negative numbers. But when we talk about integers, 0 is included in what we would define as integers. Okay, but here's the important part about integers. But they have to be whole numbers only. Okay, so what does that mean then? That means, okay, no decimals or fractions. Whole numbers only. Okay, no decimals or fractions. Okay. All right, so let's see. Let's get our integers pointed out to our description here. Okay, integers, positive, negatives, and 0, but whole numbers only. All right, so now last one, let's talk about what are absolute values. Okay, it says that absolute values, an absolute value is the distance a number is from 0. That sounds a lot like opposites, but let me show you how it's going to look a little bit different. All right, so when we talk about absolute values, you may have seen this before, but a number, either a positive or a negative number, a number will be inside these straight up and down bars. So I'm going to have -9 in here. So what's the absolute, and so those straight up and down bars mean absolute value. So what is the absolute value of -9? Well, you ask yourself, how many units is it to 0 from whatever this number is? Well, back to 0 from -9 is going to be 9, right? So the absolute value of -9 is 9. The absolute value of 9 is also 9, because how many units would it be getting back to 0? 9. So the thing to notice here is that no matter what's inside your absolute value bars, its value is going to be just the numeral stripped of any negative symbols if they're there. Okay, so I'll use these examples to show you the same. So absolute value bar, -26. Okay, so what's the value, the absolute value of -26? Simply 26. What's the absolute value of 26? Simply 26. Right? That's how those work. Doesn't matter what the number is. The absolute value of -136 is 136. The absolute value of 136 is 136. All right, see how that works? So we'll be looking at that a lot. You'll talk a lot more about absolute value when you get to 7th grade next year. We just look at it pretty simply in this one unit. All right, so that's our examples for absolute value. Okay, so some new terminology there. Let's see if I can get it all in one frame. There we go. Some new terminology there. And we'll be using this terminology throughout the rest of our lesson. So let's move on to the next page here. And this is page 85. And I have one note slip I want right up here in the corner. So I'm going to put that there real quick. All right. Okay, so here are the things that where all of our vocab we just learned comes into play. All right, so the first thing says, find and graph the opposites. I'm going to circle opposite right now of each integer. Well, the integers they are giving us are 2 and -6. But it didn't say graph 2. It didn't say graph -6. It said graph the opposites. So what's the opposite of 2? Well, it's -2. So with my light green pencil, I'm going to graph. And when we graph on a number line, we just circle in a dot right on the line. All right? And the opposite of -6 is going to be 6. So on my number line here with my light blue pencil, I'm going to graph that 6. All right? It's a nice big circle on there so we can see it. Okay? All right. The next one says, find each absolute value. Well, we just learned about absolute value, didn't we? All right. So the absolute net value of -4 is, and we use an equal sign here, because the absolute value of -4 does equal 4. All right. The absolute value of 3 does equal 3. Right? Okay, next one is, which of the following are integers? Okay, we have to remember, what are the rules for integers? Positive, negative, and 0 but they must be whole numbers. So let's look at this. Is 5 going to be? Yes, it is a whole number, positive whole number. How about negative 3? Yes, it is a negative whole number. How about negative 1 1/4? Well, 1 1/4 is not a whole number, so it is not included in the set we call integers. How about negative 4? It's a negative whole number, so yes. 0 is included as an integer, so we would circle that one too. How about negative 9 5/10? No, that is not a whole number, so it is not included in the set of integers. All right. Okay, so let's see. Next one. Write an integer to represent each situation. All right, so here we're writing integers that would represent, for example, Death Valley, California is 282 feet below sea level. Below sea level is my key word there. They've underlined it for us. So below sea level would be negative 282. Right? The stock market gained 5 points today. So what's the integer I'm going to write that represents gained? It's going to be a positive number then. So that one is just going to be 5. Okay, Patrice withdrew $15 from her savings account. Withdrew is going to be a negative number. So it's negative 15. Oh, that's not showing up very well. I think I'll get my pen out here. Negative 15, 5, and negative 282. Shows up a little better, okay? That's how we would write just a simple integer for each one of those scenarios. Okay, you'll have similar things to all of this on your worksheet when you do that. All right, so let's write a couple notes to ourselves so we remember how these work later. Up here, I'm going to write some thought bubbles. How many? Made my eraser out. Guess I didn't plan on making any colored pencil mistakes today. All right, that Y is not where I want it to be. All right, try again. All right, so how many don't fall apart. Okay, how many whole numbers back to 0? That's the question I'm asking myself when I'm looking at absolute value. So I'm gonna use my blue highlighter. How many, let's see. Okay. How many whole numbers back to 0? That's what I'm asking myself when I'm thinking of what is the value of absolute values. All right. Okay. So on integers, let's make our note for that. All right. Integers. We've got a positive, and negative. What's an integer? It has to be a positive and negative. I'm going to put this in red. Whole numbers. Whole numbers and 0. 0 gets to be included in this. All right. So that's what I should be thinking of when I'm thinking of what numbers are included as an integer. All right, so let's see where we got. That one was right here. All right, and there's my thought bubble for that one. Okay, so that gets that part of the notes done. Now we're going to move on to the content for the next lesson. Remember, we're combining 2 lessons here. So that pretty much covers what you would see in 4.1 right here. And now we're going to move on to what you would see in 4.2. 4.2 is all about comparing numbers. Can we put all these integers in order? Can we identify what's least and what's greatest? All right, so we're going to start with a note here, a question here really, that says, when is 25 smaller than 18? When is 25 smaller than 18? Well, when they are their negative, negative numbers. Okay, and we will show that briefly. Okay, so when they are, if 25 and 18 were both negative numbers, then 25 would be a smaller number than 18. Not something students are used to seeing, so it can get a little confusing, which is why we use our number lines quite a bit during this lesson. So I'm going to draw a number line here. Draw a number line there, and in about the center, I'll put 0. Try and keep these as evenly spaced as I can, and then I will number them. So I've got 1, 2, 3, and 4, 5, 6, and 7. We'll do the same thing going back the other way. Try to keep them even. It's not always easy, but we try. Okay, so -1, -2, -3, -4, -5, -6. Okay, so let's make it so they're balanced on both sides. I need a -7 here. All right, and -7. All right, now we have our number line. All right, so as we're looking at a number line from 0 to the right, those numbers are going to be getting larger and larger. Actually, I shouldn't word it that way. I shouldn't mean from 0. No matter where you are on the number line, as you're going to the right, the numbers are getting larger. All right, so let's put it this way. Larger, and then smaller, so numbers are getting larger as you move to the left, and they are getting smaller as you move to the, did I say left? Sorry. They're getting larger as you move to the right and smaller as you move to the left. All right. Okay, so there's our number line. Now we can refer to that as we look at these next practice problems here. So in our notes right under here, we're going to write -4 and 0. And with my blue pencil, I'm going to put a big circle there. Okay. Now, we're going to put in there a lesser than or greater than symbol. Well, let's look at our number line. I've got -4 is here, and 0 is here. -4 is to the left of 0, so I know that it is smaller. Okay, so we would put this symbol in here to show that -4 is smaller than 0. All right? Now, this is where students can get kind of confused when both of the numbers are negative numbers, because they want to see, they see the 3 and the 5, and you've been conditioned in learning about positive numbers that 5 is a larger number than 3. But when we're talking about negative numbers, that's not going to be true. Watch. Here's -3. Here's -5. It's farther to the left than -3, so that means it's getting smaller and smaller. So -5 is a smaller number than -3. Oh, I knew this was about to break. Darn it. Hold on a second. All right, there we go. So, so -3 is larger than -5. There we go. All right, so one more example. How about if we have -6 and 7? Okay. Well, this one should be easy because you should understand that anytime you have a negative number that you are comparing it to a positive number, all negative numbers are going to be smaller than all positive numbers. So that's going to look like that. Okay? All right. So let's see. Now we're going to talk about, use my dark green pencil again, and separate that. So that's the simple comparing of two integers. Now we're going to talk about putting a list of integers in order from least to greatest. So order, let's see what I can do right here. Order integers from least, that means smallest, to greatest, that means largest. Okay? All right, so the first set that we will order is A, and it includes 4, -3, -6, 0, and 9. All right? Now, I often think when you're learning, when you're just kind of beginning, it helps to kind of separate in first your negative and positive numbers. So I'm going to kind of show you one way. Let's say right in the middle here is where we're going to put 0. All right, and then on this side, I'll put all the numbers that are greater than 0 in order, and then all the numbers that are less than 0 in order. All right, so as it turns out, 4 is going to be up here. Is 4 the smallest of my positive numbers? Yes, it looks like it is. So I've got 4 and I've got 9. Okay, I also have a 0, so I'm going to circle this 0. And then when I go to the left of 0, I see I have -3 and I have -6. All right, now I have these all in order. So I know, and count them too, so make sure you don't forget anything. So 1, 2, 3, 4, 5, yes. 1, 2, 3, 4, 5, and yes, they are in order. So then right underneath here, I'm going to write -6, -3, 0, 4, and 9. Now they're all in order from least to greatest. All right? Okay, B. My numbers for the set on B are 8, 4. Oh, I ran out of frame there. Sorry, I didn't notice. Okay, 8, 4, -5, -4, 0, and -7. All right, well, I'm going to do the same thing right about the 0, right about the middle. I'm going to call that 0. All right, so what do I have to the positive? Well, I have 0, so I'm going to circle that right now. And I have a 4 and an 8. Those are my only positive numbers. So 4 and 8. All right, now my negative numbers. Okay, so practice problems for lesson 4.1 and 4.2. They're pretty much just the same things we went through on the notes and what you will find on your worksheet. So let's get the first set in frame here. You may pause and work these out. And the next part of the page in frame. Okay, let's work these out. All right, these go really fast. Okay, so here's how it would work. Find the opposite of each number. So the opposite of 8 is -8. When I see students working on these problems on their worksheet, they often want to put an equal sign there. Don't do that. Is 8 equal to -8? No, it is not. We're just writing down the opposite number, but they are not equal. Right? So the opposite of -1 is 1. The opposite of 1 6/10 is -1 6/10. The opposite of 3/4 is -3/4. So there's our answers on that one. I think I'm going to give them a little soft circle there to make them stand out a little better. There we go. There's your opposites. All right. Draw a number line from -5 to 5 and graph these numbers. All right, here we go. Number line 0 in the middle. All right, I've got 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Not bad. Okay, we've got to number them. And we're negative on this side. All right, and it's asking us to graph 2, -4, and -2. All right, so 2 is right here on the number line. -4 is right here on the number line. And -2 is right here on the number line. All right, that's those three numbers graphed. All right, let's talk about finding absolute values. So absolute values. So in absolute values, we do use the equal sign. We don't when we're writing down opposite numbers. We do with the absolute values because the absolute value of 9 does equal 9. The absolute value of -1 does equal 1. The absolute value of -14 equals 14. Okay? The absolute value of 2, and you know, I should point out, we've been talking about integers and how integers are whole numbers. When we're talking about absolute values or number lines in general, it doesn't have to be whole numbers anyway. Any number that can be graphed on a number line is a number. It's not an integer, but absolute value doesn't apply to just integers. So absolute value of 2 1/4 is 2 1/4. Absolute value of -6 8/10 is 6 8/10. Absolute value of 6 is 6. All right. Let's go ahead and do this. All right, so that's the absolute values. Now, let's look at comparing our numbers, right? So 9, is 9 less than or greater than 11? Well, we know that 9, these are both positive numbers, and 9 is a smaller number than 11, right? 5, is it less than or greater than 0? 5 is greater than 0. Okay. 0, is it less than or greater than -2? Well, -2 is to the left of 0, so I know 0 is greater than any negative number. All right. -8 and -3. Okay, remember how they work when you're on the negative side of the number line. The larger the absolute value here, the smaller the number. So -8 is going to be farther to the left on the number line than -3, which makes it smaller than -3. Okay. Now, anytime you have a negative number and a positive number, you know the negative number is smaller than a positive number. Oh, we've got two negatives again, so let's take a look at that. So -22, well, -25 is going to be farther to the left on the number line, so it is smaller. That means -22 is greater than -25. All right. Okay, so now last part is ordering these numbers from least to greatest. So let's see, I have one negative number, so I know that's going to come first, -1. And I have a 0, so I know that'll be next. And now I have a 3 and a 4. Well, 3 comes before 4. That was easy, right? All right, let's look at my negative numbers first. I have a -2 and a -1. -2 is smaller than -1, so that'll go like that. I have a 0, so I'll get that in there. Now let's look at my positive numbers, a 5 and a 2. 2 comes before 5, and so that orders them. All right. Okay, here, negative. Oh, they're all negative numbers. All right. So it's going to be -72 is going to be my smallest number. -72. -40 will be next. And -29 will be next. And -21 is the largest in this set. And the last one, let's see, I have two negative numbers here. -21 is the smallest of those two negative numbers. Then -17, and I have a 0, so that goes next. Then looking at my positive numbers, I have 17 and 21. So 17 comes before 21, and now they are all in order. All right, so that's your practice problems for lesson 4.1, 4.2. Let's take a quick look at your worksheet. Your worksheet is we don't usually see this on our worksheet, so let me point it out. The worksheet is two-sided. Okay, the 4.1 problems are on one side, the 4.2 problems are on the other side. Don't worry though, I mean, it looks like a whole lot of work, but did you see how fast we were able to work through those practice problems? These go very fast. Most of my students can do both sides within 15 minutes. So it's not as much work as it looks like. And all of these are things we have done in the notes and in the practice problems. So you've got find the opposite of each number. Remember, on finding the opposites, we don't put equal signs. The opposites are not equal to each other. Graph the number 4 and its opposite. So you might want to box and its opposite. All right, so don't just graph number 4. We're graphing number 4 and its opposite. On number 8, we're just talking about graphing these numbers on the line. On number 9, you're going to circle, just like we did in our notes, the ones that are integers, and don't circle the ones that are not. Okay, absolute values, this is where you should have an equal sign. The absolute value of -11 equals, and the answer there. Okay, and this part down here is write the integer that represents these things. So as you're looking at these situations, think about, are they going up or are they going down? Are they above or are they below? That'll give you your answers for whether these are going to be negative or positive integers. And then this last one down here, it says name the integer represented by each point. All they mean is each one of these letters where you see one of these points on the line, what is the number, the integer that is represented by this M point. Okay, they haven't labeled all of the little tick marks, just a few to give you an idea. So you've got to figure out the rest. All right, then on the other side, it starts out with some simple compare with a less than or equal than sign. And these are the ones where you're putting them in order from least to greatest. Okay, this is a table where first you're going to write the integer that represents these numbers, and then you'll put these numbers all in order from least to greatest. All right, and then name 5 integers between these two numbers. If you're having difficulty with that, refer to a number line. On this one, it's asking you less than, greater than, or equal to. So you need to remember again, what does an absolute value mean? So before you can compare these, you have to write down underneath, what's the absolute value of 10? What's the absolute value of 8? And then compare those numbers with the less than, greater than, or equal to symbol. It will matter. You can see it here, and if you really understand it, you don't have to write the numbers underneath, but if you're having trouble grasping how it makes a difference, do that. All right, so that leaves us with our exit problem, and the exit problem is really small. There we go, that should be better. So this is the exit problems for the combined lesson 4.1 and 4.2. And remember, I don't give answers on this one. This is just extra practice for you. Your teacher may use it as an assessment or in some other way. All right, so that is lesson 4.1 and 4.2 combined out of the book of Introduction to Algebra. All right, so remember, the only way to learn math is to do math, and mistakes are proof that you're learning.